Hey everyone, so we are going to dive into your last video for this chapter, which is all about U substitution for finding antiderivatives. So we've been talking about finding the area between the curve and the x-axis, right? And we started out using geometry, then we started using approximations, then we talked about antiderivatives, but the thing is that sometimes undoing some of these derivatives is a little tricky. So we have to talk about what to do. So if you think back to when we talked about derivatives, one of our rules that we talked about was the chain rule. All right, and so what we're going to be doing now is we're going to be exploring how to undo the chain rule. So let's first look at this example here. We want to take the derivative of e to the sine of x. So what we want to do is think about how to take the derivative of e to some power. We know that that's just itself, so e to the sine of x. And then we need to multiply by the derivative of sine. That's where the chain comes in. So we're going to multiply by the derivative of sine, which is cosine of x. All right, so since we're working with finding antiderivatives to compute these areas, we have to undo the chain rule. So we call this method U substitution. So again, the big idea here is we're getting rid of the chain from the chain rule. So we have to talk about how to do that. So we've got these steps here that we're going to follow. We're going to go through this example very in detail, step by step. Then we'll do 2 of the examples in the video, and we'll do the rest in class tomorrow. So let's take a look at this integral of sine of x times e to the cosine x dx. We know that we are going to have to use U substitution here because when we look at what this function is, I cannot think of a single function where this is the derivative, right? I can't use one of the rules that we've been talking about. So instead, we're going to have to look at how to use U substitution. So the first thing we have to do is choose a function to be U. So make yourselves a note here, and we want whatever is causing the chain. All right, so whatever function caused the chain is what we want to turn into a u. All right, so when we look here, we've got sine of x times e to the cosine of x. Well, taking the derivative of sine of x, that's pretty straightforward. All right, and then we have e to the power of the cosine. Well, cosine x then is what I'm going to want to take and change into a u. So I'm going to go over to the side here, and I'm just going to actually write that. U equals the cosine of x. All right, that cosine of x being there is what caused us to use the chain rule. The second step is that we have to take the derivative. We have to calculate du. So it's take the derivative. Which really means we're going to find du dx. As long as we're in terms of x here, all right? So let's take a look at our function here. We have u equals cosine of x, so that means then that du dx is going to equal negative sine of x. All right. The next step here, it's listed as one step, but it's actually, we're going to do it in 2 steps. So the first thing that we have to do there is we have to solve for dx. All right, so looking at this right here, du over dx equals negative sine of x, we need to solve this for dx. So I'm going to do it in a couple of steps here, but most of the time I'll just do it in 1 step. So I'm going to rewrite it, du dx is equal to negative sine x. And I know that if I want to get rid of this dx, I can just multiply both sides by dx. So this cancels. And I get du is equal to negative sine x dx. And now if I want to get dx by itself, I can divide both sides by negative sine of x. So I get dx is equal to du over negative sine x. All right, so all we've done is rearranged this orange function into the purple one, okay? But now the next step of our u substitution is to actually substitute. All right, so we need to look at what our integral is over here, and we are going to have to substitute in anything that we wanted to get rid of. So if we've got, I'm going to put a box around dx right here, because that's what we solved for there. And I'm also going to put a box around the u. Both of these are things that we're going to take and actually substitute into our integral. So I'm going to take the integral and just rewrite it first, so my integral symbol, but I'm not going to worry about my bounds right now. All right, and when I look at this, sine of x didn't go anywhere, so I'm just going to rewrite sine of x times e, that didn't go anywhere either, but instead of cosine of x being my exponent, that's where the u is going to go in. Okay, and then instead of this dx right here, I want to put in du over negative sine. Now when we look at this, we should be able to cancel anything that has an x. So sine of x cancels with the sine of x, and we've still got a negative sign, so we have the integral of negative e to the u du. Now everything is in terms of u. If whatever you have here doesn't cancel, if it's got x's, then you know you did something wrong. That's a time for you to go back and see if maybe you picked the wrong function to be u, or if you took the derivative incorrectly, but all of the x's should cancel. All right? Let's take a look at step 4 then. So step 4 is that we have to change the bounds for u. So if you take a look at the original integral, we were integrating from 0 to pi, but that was when our functions were in terms of x. Now our function is in terms of u, and so we need our bounds to be in terms of u. So what I'm going to do is down here underneath, I know I'm outside of the box, sorry, but instead of x being 0, I want to know what u that would be. So I'm going to do u of 0. Which really just means since u is cosine of x, that means I'm going to do the cosine of 0. And we know that the cosine of 0 is equal to 1. So my lower bound on my integral is going to be 1. And then I'm going to figure out my upper bound. So u of pi means do the cosine of pi. So that's negative 1. So my upper bound is actually negative 1. Now, from this step, everything that we are going to do is stuff that we've already been doing. We're going to take the antiderivative and then just evaluate the integral. So negative e to the u du is super simple now. We took this messy thing up here and we made it something that's really easy to integrate. So we know that the antiderivative of e to the u is just e to the u, and we're going to bring the negative along with it and put a plus c. And we're going to evaluate from 1 to negative 1, which means we're going to have negative e to the negative 1 plus c minus negative e to the first plus c. So negative e to the negative 1 plus c plus e, because I'm going to distribute my negative, and then minus c. So the c's end up canceling, and we get that the integral is equal to negative e to the negative 1 plus e. And that's our final answer there. So you'll notice everything over on the left here was kind of my extra work that I needed to do in order to be able to compute this integral. Everything over here has to be done in order to be able to do the work here. All right, I'm going to kind of box this off so that we can go ahead and look at the next example. Sorry that I went a little bit out of the box there. But let's take a look at another example then. So, taking a look at this integral, the first thing we want to do is we want to figure out what's causing the chain. What do we want to take and turn into a u? Well, on the top here we have a 4x, and on the bottom we have 2x squared plus 1 quantity squared. Well, since this on the bottom isn't just x squared, we know that that stuff in there is what's causing the chain. That's what we want to take and use to be the u. So u is going to equal 2x squared plus 1. Second step here is that we want to take the derivative. So we're going to say du dx is equal to 4x. Step 3, we want to solve for dx. So again, we're going to multiply both sides by dx, and then we'll end up dividing by 4x. So just to show that step, du equals 4x times dx, and then we can divide both sides by 4x so that we get dx is equal to du over 4x. All right, and now we are going to actually look at our integral and start to substitute. So I'm going to go ahead and put an equal sign here and draw my integral. Now the 4x isn't going to go anywhere. It doesn't get anything substituted in for it. And on the bottom though, that's where my u is going to go. So I'm going to grab my green and I'm going to put u squared. And then times, I want to substitute in for dx. So instead of dx, I'm going to put in du over 4x. Again, I'm not going to put my bounds of integration yet because I still need to figure those out. So I'm going to worry about getting my function taken care of and then go back and worry about my bounds. So if I look here, 4x and 4x cancel each other. So I get that my integral is 1 over u squared du. And I am actually right away going to go ahead and rewrite that as u to the negative second du, because it's going to be easier to take the antiderivative when I have my negative exponent there instead. All right, now we are ready to figure out what the bounds are for our integral. So again, we're going to take the original bounds and we're going to plug them in to the function here for u to figure out what the u bounds are. So u of negative 1 means take negative 1 and plug it in. So negative 1 squared is 1 times 2 is 2 plus 1 is 3. So that means my lower bound is 3. And then for my upper bound, I'm going to do u of 2. So 2 squared is 4 times 2 is 8 plus 1 is 9. So now my upper bound is 9. And now everything from here is everything that we've been doing since we started taking antiderivatives. So the antiderivative here, I'm going to undo the power rule. So I'm going to add 1 to the exponent and divide by the new exponent, which means I need a negative 1 in front, plus c, and I'm going to evaluate this from 3 to 9. So instead of negative 1 u to the negative 1, I'm going to go ahead and actually rewrite that as negative 1 over u plus c and evaluate it from 9 to 3. So that means I'm going to have negative 1 over 9 plus c minus negative 1 over 3 plus c. And so if I distribute my negative, I'm actually going to have a plus 1/3 and a minus c. So those cancel each other. And I'm going to need to get a common denominator here. So that means negative 1 over 9 plus 3 over 9. And I get an answer of 2 over 9 for this integral. All right, we are going to do one more just to make sure you guys are okay with this. So I want you to take a look at number 2 here, and I want you to see if you can figure out what the u is going to be for question number 2. So when you're looking at this, what you're looking for is the function that is causing the chain. Well, the other thing we can look at is we've got tangent x times secant squared of x. we know that the derivative of tangent is secant squared. That means then if I pick tangent to be my u, I'll have a really nice substitution because it's going to end up canceling. So u is equal to the tangent of x. And then I'm going to go ahead and take the derivative. So that means du dx is equal to secant squared of x. And if I solve for dx, I'm going to get du over secant squared x. Again, we'll multiply both sides by dx and then divide by secant squared. So that's how we get to there. And we're going to go ahead and substitute now. So that means I'm going to do my integral. Tangent of x is what I am turning into a u. So I'm going to put u times secant squared of x times, instead of dx, I want to put in du over secant squared of x. And I messed up with my colors, but that's okay. Now go ahead and take a look and see what cancels. So secant squared of x cancels with secant squared of x, and we're left with the integral of u du, which is again something really nice that we're going to be able to take the antiderivative of. Now we just need to look at those bounds. So I want to change it from 0 and pi over 3. So I'm going to go ahead just right here, and I'm going to do u of 0, which means the tangent of 0. And we know that the tangent of 0 is 0 still. And then we want u of pi over 3. So the tangent of pi over 3, which is the square root of 3. So I'm going to evaluate this integral from 0 to the square root of 3. And now from here it's everything we've already been doing. So the antiderivative there is going to be 1/2 u squared plus c, evaluated from 0 to the square root of 3. So 1/2 root 3 squared plus c minus 1/2 0 squared plus c. And so we end up getting 3/2 plus c minus 0 minus c. The c's cancel, excuse me, and we're left with the final answer of 3 over 2. Alright, I know that was a little bit longer in the video, sorry about that, but I feel like it's important for you guys to really understand where these are coming from. We'll do examples 3 and 4 together as a class before you guys dive into the practice in your packet, but you will get lots and lots of practice before our test next week. Alright, see you guys later. Bye!